Good to go. Good morning, everyone. Jim Braddock, Director of Sales here at our American headquarters in Austin, Texas. I would like to thank everyone for joining this meeting. Also, the presentation will also be recorded. Today we have Stefan and Jeremy from BASF Powder Bed Division to cover some of the latest offerings in material to advance additive manufacturing for full-scale production. I will let Jeremy and Stefan introduce themselves and thank you again and hope the meeting is informative.
All right, thank you. Happy to be here. Happy for and thankful for the invitation to present our powder portfolio live from Farsoon America's headquarters. It's good to be here, see everything live, the people and the machines. I'm Stefan Josupeit. I'm heading the business line Powder Bed Fusion within BASF, 3D Printing Solutions Group. I'm originally based in Heidelberg, Germany, but today on the road in the US, and I'm happy to speak today.
Thanks, Stefan. Jeremy Voss here. I have commercially responsible for powder bed in North America. So I get to travel around and enjoy meeting with our customers. And like Stefan said, great to be here at Farsoon headquarters in North America in sunny Austin, Texas. Going to be a beautiful day today. So we are excited to present. Stefan is going to be driving the slides and doing most of the content today. I'll be watching the watching for comments and questions, and I'll also be interjecting from time to time with questions that come in. And so we want this to be more of a conversation, really, or at least kind of a conversation style. So if you have questions as they come up, type them in the chat, or feel free to click the little button, raise your hand, and we'll take frequent breaks to answer questions, because we do want this to be more of a conversation and less of a presentation. So feel free to jump in. I'll be watching for questions, and I would really look forward to your participation and finding out more. So thanks again for being here.
Cool. So we'll kick it off. So the introduction was already made. As said, my name and my function within BASF. I want to dive right into the agenda for the talk today. So first of all, we would like to give a quick introduction into what is BASF Forward AM doing, what is our company mission, what are the fields that we work on, and what is the relation between BASF and Farsoon in history and today. Right after, I will dive into the PBF product portfolio, followed by key applications, because each material innovation needs to have a target industry, a target application, to use the full value of additive manufacturing and the machine material combinations. Very importantly, we would like to give an idea how to get started in the end, because it's an open platform, open material supply, and we want to give the best guidance in getting started on new machines and new materials. And we're closing on a snapshot on sustainability aspects, followed by Q&A. But as Jeremy said, Q&A also welcome in between. So I want to dive into the mission of BASF Forward AM, and our slogan is "The only way forward is together." To us, it's a clear mission that it requires collaboration and teamwork, because the future of 3D printing in the end depends on the ability to work together. And this is very important. It's not only hardware systems, it's machines, it's materials, it's parameters, it's knowledge, it's design, and in the end, it's the end user and the application that is using the value of the combination. And we want to collaborate and win this together. That's why also we are especially happy to be at our good partners Farsoon today. See it here live on stage and make a joint presentation. A brief history of the 3D printing activities in BASF. They originate from, in the end, with all the pre-work done, more than 10 years ago, but were intensified with the opening of the company BASF 3D Printing Solutions in Heidelberg in 2016. That's when I also joined the company. And since then, many things happened. Especially, I don't want to go through all the details, but what are the major cornerstones, especially in PBF and our global footprint, is the opening of our application technology centers, one in Corktown next to Detroit in the US, another ATC in Shanghai. And with this, we have basically 3 centers, including the one in Germany, that we use to develop applications for our joint customers. In regard to PBF, especially, I would like to highlight the acquisition of Advanced 3D Materials and Setup Performance in 2018, which is basically our sole powder R&D and pilot production hub that allows us to act very, very flexibly and fast in order to meet the customer's need and also to provide custom materials on demand if that is needed. And we can do all that very fast. Just very recently, we had launched our Project Zero, which is a mission to allow for more intense activities in regard of sustainability activities, for example, in life cycle analysis, carbon compensation, and reduction of the environmental impact of additive manufacturing. All this we are doing to be the AM solution provider of choice and addressing the market needs together with our partners.
Let me bounce in here, Stefan, with a couple of things. I wanted to just add some clarity. One of those being, or there's two acronyms that we've been using that I wanted to make sure that we we all understood, because we have a tendency to throw them around. One of them is PBF, so that stands for powder bed fusion. Another word for that could be SLS, right? Selective laser sintering. Kind of they're interchangeable terms. But as you hear us throw around the phrase PBF, that's how we talk about our group internally, and it means the same as SLS, or even we've heard the high-speed sintering, HSS, put out there as a slightly different type of technology, but they're all in that same group, right? It's all polymer powder bed technology. The other acronym that I wanted to clarify is ATC. And that stands for Application Technology Center. So these are centers in, like Stefan was talking about, there's one in North America that's in Detroit. There's one in Germany, in Heidelberg, and there's also one in Shanghai. And these are places where we have technicians and scientists and printers where we combine applications with technology. So the combination of a printer and machine and material that all go together to make an application. So I just wanted to add a little bit of clarity to those two acronyms, because inside of BASF especially, we throw around a lot of acronyms. So thanks, appreciate it.
All right, thank you, Jeremy. Yeah, quick snapshot about our global footprint here and also the number of people involved. You see that the cornerstone of our activities is in Europe, with all the R&D teams, with the production sites, and with the product and central functions, but of course with the global teams, as Jeremy said, to be on site, provide technical assistance, business assistance, and all the technical needs that are needed in order to drive application development. I said already earlier, it's about collaborations in the industry, and what we are doing is going hand in hand with the major additive manufacturing companies and leaders in the industry. So we are not restricted to any certain technology or any certain hardware type. And I think it's the mix that makes it for each application, and a strong collaboration between us, the customers, and especially the hardware manufacturers, in order to jointly create value. And I want to especially highlight the collaboration with Farsoon, which is originating since, I think, more or less 10 years or so, or more or less since the founding. And in that time, BASF and Farsoon have already created a lot of different custom applications and proven our joint footprint in the industry. One big aspect in our activities, as said, are sustainability aspects. We had launched, for example, a sustainability award that was held in Barcelona last year. We're a member in the AMGTA that covers sustainability aspects within the additive manufacturing industry. And as said, we had launched Project Zero to provide transparency and reduce environmental footprint of our materials. All this is being done to support innovative companies to solve additive manufacturing challenges in various industries. It doesn't matter if it's industrial, if it's orthopedic, if it's medical, if it's in the consumer segment. It's quite wide, and this, I think, makes also the fun to work in the industry. as we never know exactly, okay, which project or which application will be enabled tomorrow. And we're excited about it and working together with you. Overall, we're not only working in powders, even though powders are focused today. So this is just a brief side information that also photopolymers, metal and polymer filaments, with a lot of enabled machine material combinations are part of the portfolio. Quick insight into Farsoon and BASF. The photo on the right-hand side is the very recent addition of a Farsoon machine to our machine park in the ATC in Detroit. It's a Farsoon HT43 double flight. But this is not the only machine. Actually, the very first Farsoon machines that were sent outside China at that time in 2015, 2016 were shipped to BASF. And they're still running today. So I can confirm a high consistency and durability of the equipment, which is running daily in our labs to develop both materials, but also the applications around it. And I think I can firmly say Farsoon and BASF have the joint target to drive industrial applications and drive innovative solutions with cool materials and cool technology to the additive world. With that, I'm done with the overall introduction part and want to switch over to the product portfolio. Overall, in the PBF segment, we are running 5 different product lines. I will quickly go through them and provide some basic aspects of the portfolio later. So one product line, which is one of our focus lines, is TPU, so thermoplastic polyurethane materials. We offer those materials for several different powder bed technologies, including SLS, with the TPU88A and TPU88A Black, that lend themselves especially for any application requiring flexibility. And I'm especially excited about the wide field of applications that we can roll the material out to by just changing designs and play with different geometries. I will have some examples later. Another product line is PA11. So it's a polyamide line, a material quite similar to PA12, but having the additional features of being bio-based. So these materials are made of castor oil, and in addition offering a bit higher ductility and additional certifications, for example, for skin and food contact. Also being available in modified version, functionalized versions, like carbon fiber reinforced or electrostatic dissipative. Then the bottom line here is polypropylene. Polypropylene is also a product line out of our core business, where we also offer several grades to the industry, including PP1400 Black, which is, for example, also well compatible with Farsoon flight technologies. 2 other materials also in line, not in the core focus today, is polyamide 6. There we have a grade with mineral fiber reinforcement. That is basically a high performance grade for demanding applications in high temperature environments where high strength and high stiffness is needed. And another recent addition to our portfolio, which is AP26, which is one of the few materials in the market that really do not need any refresh in the powder bed fusion cycles. So that material really allows for 100% of material usage and 0 waste. And by that enables applications looking for any kind of form and fit prototyping, but also keeping in mind sustainability, that we really do not have any need to throw powder away anymore, which is, I think, a very, very big advantage in the industry, where still a lot of material cannot be used 100%. Looking into the powder portfolio in detail, first of all, into the flexible materials. We have one TPU, which is special for MJF technology, but I want to specially highlight today TPU88A white and black, which are available to the open SLS market, including Farsoon machines. And we have made amazing experience in several different industries, from, for example, sports and protective gear industry. We had run several projects in the automotive area, not only for bridge production, partially also even for serial production. We see a lot of potential in the consumer segment, for example, the footwear industry or the personal protection industry. and of course, one of the major industries for powder bed fusion, healthcare, O&P industry, any application where a flexible part is needed that goes in contact with human skin, that is fully approved for use of TPU 88A. That especially lends itself for the SLS process due to low smoke emission, high rebound elasticity, and a super ease of use on the machines. If we look into the more rigid part of the powder portfolio, there's a bit higher diversity of material classes. Looking from left to right to deep dive a bit, as told earlier, the PA6MF is more the high performance material in the portfolio for special applications requiring high stiffness and strength in even high temperature environment. The next one is polypropylene, so it's a more commodity, belongs to the commodity polymers that are enabled for powder bed fusion technology and being used in SLS since quite a while, even though still being a niche. We see a lot of emerging applications and markets about materials that enter the PBF world, including PP, that of course especially is used because of a lower density. So you need less material to fill a machine. You can print lightweight parts in several industries, and it is especially intrinsically chemically resistant, so that it's not sensitive to any moisture or any or many chemicals that could go in contact with the material. And PP is especially used in some consumer applications, but also any kind of tubes or flow or storage parts where any kind of fluids need to be transported or stored. Then the next three ones are basically the PA11 portfolio. We have that available in unfilled black and white. The black again working well on Farsoon flight technology, especially boosting ductility. It's the toughest material in the market in Sharpie or ISO impact tests. And it is also for many applications a nice drop in for PA12 materials, just because we have the bio-based feature, we have the higher ductility feature, and we have additional certifications like food or skin contact. If it's more functional, then we are looking into the carbon fiber grades, for example. I later also show an application example to see, okay, how can really such high strength, high stiffness material be used to reduce weight of a part in application. And then on the very right-hand side, the AP26 boosting exceptional detail resolution, even though the material can be used or reused 100%. So the refresh rate is in the end 0, meaning we have a zero waste production, and we especially look into applications where we have form and fit of any part, where basically having a part in hand is the major requirement, but not limited to that. So we even look into some functional applications in the industrial segment there.
Stefan, we had a question about the TPU, and this is one that I get a lot. Great question. Thanks, Michael. So there is only the one hardness available, which is the 88A. But printed TPU is a different animal than other TPUs out there, than traditionally manufactured TPUs, I should say, because with those printed parts, you can tailor that part to be a wide range of hardness. So with a lattice structure or lattices inside or different thicknesses of the parts, you can actually tailor how thick that or how hard that TPU part is. So the 88A rating that's based on a 1 millimeter or a 3 millimeter cube?
Mm-hmm.
Is that right? So a 3 millimeter solid cube is the 88 is a short 88A. So by varying the part density and the structure, you can actually change the hardness of the material or the hardness of the final part. So Stefan's got a few slides coming up as well that have more detail on that. But great question. I wanted to throw it out there so that we could talk about it.
Yeah.
Cool. Keep coming with the questions. Thank you. Appreciate it a lot.
All right. There was basically a brief snapshot of the portfolio. Some applications will follow later. I want to highlight also quality aspects because we are working in a quite sensitive production process, which is about thermal consistency, material consistency, flow, and everybody who works on PBF knows all that potentially tricky points. And what we have put on our roadmap is a clear quality management concept. So we, on the one hand, offer top-notch technical assessment if needed on site. We track all topics or questions that could pop up. And very important, we track production consistency as a requirement straight from R&D, meaning all the materials that we scale up that come out of pilot production are very closely interacting with the production teams so that we basically can define specifications and know all the dependencies from the production that we fully control ourselves. Last but not least, every lot that leaves our warehouse is being tested in our lab in regard to printability and part properties, which is a very important aspect because we put that on top of the analytical QC of the COA that we provide, so that we can really prove that the material has been working and were approved and validated on our machines before shipping. With that, I want to conclude the brief insight into powder product portfolio. If there are any detailed questions, because the portfolio is quite wide, we're happy to answer that afterwards. Otherwise, I would switch over to key applications that we look into from diverse markets with diverse materials. One aspect into application development and typical hurdles we see, independent on the material or the technology used, I would like to highlight is first of all process qualification. There is still a lack of international standards and qualification procedures with each customer. When do we say, okay, that is a working system, that is a high quality, and that is I think a very important aspect where we need to all work closely together in order to specify the best processing quality for each kind of application. And of course, providing the certificates and procedures and material tests needed in order to prove the consistency of a production system. The next one is knowledge about 3D that is independent on the performance of any material that we supply. It's still a big hurdle. That's why we also working closely on fairs, on trainings, on outside 3D printing community activities, because I think one of the biggest hurdles is knowing about the potential and the great opportunities and the value that 3D printing can provide to the industry, and especially with the highly productive machines. I mean, we have seen some here in the right around the corner in the Farsoon lab that really offer high throughput, high productivity, high automation levels. And I think it's really about the awareness that even scale production projects are possible today already, and that the break even by number of parts is basically shifted to higher volumes every day. And that's, I think, good news for the industry, but it could be better known to the outside world. Another aspect here is cost. It's not only about material cost, it's about, in the end, the final cost per part, which is determined by machine, by material, by productivity, by labor, by automation level. And I'm especially happy that there is progress on the automation, both in the machine segments, not only with Farsoon, but also in the pre and post processing capabilities. Last but not least, it's about proven sustainability. We very often hear, okay, 3D printing is in general more sustainable, and I think that's a very dangerous statement, because it's not in all the cases. And what we want to do, and what we are doing, is providing full transparency on the environmental impact of our materials, and also the offer to calculate the environmental impact of a production system. What does it mean, and where's the break even on sustainability aspects? That also has its limit, but depending on the application, on the life cycle of the part, additive can have a big advantage there, but it needs to be proven. It's not like a per se advantage, and that's why I think a lot of more education is needed in that regard. overall, when bringing a material to an application, unfortunately, it's not always that easy or that straightforward. So I think what's very important is that a production process accounts for way more aspects than simply printing a part, and we are fully aware of that. So in the center down here, it's the material and the printing process, but the material has influence on everything before and after the road from a material to an application development. It starts in the design for additive, it proceeds on simulation in material models if needed. Of course, it includes a commercial element, like what is the cost of production, the testing, the finishing, and last but not least, the environmental impact. And all this comes together for each application. And we are aware and we support our material-related influence on all those aspects. For example, by offering material models or coding technologies or sustainability calculations, because in the end, it's never about a material. So we do not understand ourselves as pure material provider, even though that maybe that's the final delivery form. But in order to make best use of it, together with our partners, we support in solution development. And solution means basically the full development chain from the idea to the design, to the printing and quality check and the final application of the part. And all these needs to be pulled together in order to make best use. I promised to look into some applications. One of the most versatile materials, that's why this graph is also quite full, is on TPU. And TPU is the material where we are most excited about the high variety of applications that are being realized. As you can see here from the consumer sector, it's in footwear, in fashion shoes, in special shoes, up to personal protection and the bike industry, for example, bike saddles. It goes into completely different industries like automotive. We have projects going on in automotive car seating, in bridge production, in production aids, soft touch tooling, for example. But it could also be completely different use of materials in tooling, for example, protection for robots, in production aids like this clamp for wind turbines, but also the medical segment. So it's hard to say, okay, that is the only target industry for TPU. It's really a lot. And we have published a lot of use cases on our website in order to provide some information and details on how the additive manufacturing based on TPU provided value for each industry and application, and to open the mind that the applications are maybe a bit wider than we initially see when we just have a flexible part in hand, because it's really a lot and really versatile. To give you one example, this is a snapshot from a concept car that BASF and Citroën in France published last year at the auto show, and the whole interior is here and there added with 3D printed TPU parts, including the whole seat shell. So the seat that you see, the whole backrest is based on a big TPU part that was printed in a big SLS machine, and then coated with our Ultra Cure 3D flexible coating. And what this concept car should provide, of course, as a concept car, it's not a serial production, even though the material is used in serial production in other projects, but it shows the capabilities of the material, what's possible in design, but also what's possible in economical and ecological aspects, as the majority of that car is made out of monomaterial, so that a recycling stream after end of life is enabled way easier than with multi-material combinations. So we're playing more with the design and the same material in order to provide greater functionality. Another deep dive into TPU use case, especially using lattices, is in protective gear, for example, helmets. So why TPU was used here? Of course, it's a it's person-specific geometry, but also about a real performance and calculation of the performance of the lattice. For example, for repeated impact gear, so it's about shock resistance, it's about coating and skin contact, and about hydrolysis resistance. Of course, that parts come in contact with sweat. and the TPU is very stable against that. And even though it's a bit tricky to see here on the picture, there is a lot of knowledge into how a lattice needs to be designed in order to make best use out of it. And I want to give just to give an idea on several lattice types that could be on the market that have a completely different, I'm sorry, it's in German, it's the force and the strain rate diagram here. And depending on the application, what needs to be fulfilled, it needs to be a very, very specific type of geometry and a specific dimension of that geometry. For example, in helmets and protectors, you need high energy absorption. So that would be a curve that basically has a high space underneath it, so that a lot of energy is absorbed. If it's about low energy absorption, more a cushioning, then the curve is lower. If it's again a footwear application and we need rebound, it's about high linear stiffness. So to really have a really stiff geometry, or the other way around. If it's about a comfort lattice, it's even the other way around, so that we have a soft lattice. And by that, as we have also all the material models behind in our databases, we can very, very precisely calculate the response of a lattice and predict the behavior and adapt it to each use. Doesn't matter if it's a helmet or a mattress or a shoe that needs to be adapted to the optimum 3D lattice design. And this is basically ordered from our service team globally in order to develop applications, not only by material, but also by perfect integration into the design chain. Switching back from TPU, here is an example for realizing applications in PA11CF. As said, PA11CF it's a bio-based polymer reinforced with carbon fibers. And what we did there is, together with the bike manufacturer Canyon, we developed a bracket that holds the bike computer mount next to the steering wheel. And the idea was to have a lightweight part that is adapted to the design of the bike, meaning that it's a multi-target optimization. It's not only about mechanical properties or behaviors like vibration or design or stiffnesses. It's also about the design. And when we came there with the very first design on the left-hand side there, yeah, that is the classical topology optimized design. Okay, nice, it works good, but it didn't fit to the design. So that meaning many different targets had to be matched. And the final design and part is today produced in series production. So thousands of parts are being produced on Farsoon machines, and the part is in the end publicly available since end of last year. And even cooler, when the part is ordered in the web shop of Canyon, they really see also the simple fact that it's a 3D printed part. It's part of the value proposition of the part. And even the name says BASF Forward AM computer mount and not just computer mount, because it's a real value that the clients of Canyon see to have a performance and lightweight and cool design part. And I think that's a good example how the interaction with a good technology, a material, a client, simulation technology is needed in order to create the best value and squeeze the best performance out of the additive system. The last example I want to show here as a general segment in orthopedic and prosthetics. It's a big application field for powder bed fusion in general, as it's about lot size 1 and patient-specific geometries. For some applications that require stiff parts like braces, where PA11 as a biosourced and sustainable material is the optimum choice. But for some applications, for example, socket inserts or insoles, where flexibility is needed, TPU can also be used. And the good point is that both materials are changeable by the design from stiff to flexible with individual designs, including skin contact approval, and if needed, the possibility to chemically smooth, to coat or dye, to also work on the part aesthetics and cleanability. And with that, we see a big potential and roll out additional applications in the O&P segment based on P11, partially also PP and TPU. That was basically the snapshot into key applications If needed, open for questions in between. Okay. Then I proceed on the how to get started. So how does it work? How to get started? In the end, we have all our materials pre-qualified on the most common powder bed fusion machines in our lab. So we have a full set of production parameters that are combined in a processing guideline, which is basically a mini handbook that gives some parameter recommendations and troubleshooting in order to set up a printing process, including listing, of course, the printer compatibility. We are supplying the materials to the open market, meaning that anybody can go and get the materials delivered to its site and putting that on your machine. And what we do basically is to guide that process very closely with our technical service team by being available on the phone, by mail, by chat, by video, or also on site in order to allow for a most smooth adaptation process. Because in the end, we know that also sometimes parameters need to be adjusted. If it's another part geometry, another filling grade, another special exposure strategy that is needed in order to fulfill or obtain special part behaviors. And we do that all together. So nobody is left alone in the onboarding process based on documentation and technical service. So that is basically on the processing part. But of course, it's also about the application development part. We offer a quite extensive set of technical data sheets, for example, that provide all the technical information on mechanical properties, electrical properties, flame retardancies, anything that is needed in order to estimate the suitability of a material for an additive application. And we are providing the certificates and extended technical data on request. And if needed, we also do additional part testing if it's needed to validate the suitability of a material and a part for the application. And with those two aspects, we are very, very close to the application and close to the production process in order to enable scale production and fast onboarding of new materials. The last topic I'm bringing today is a brief snapshot into, okay, what is being done actually in sustainability aspects. And to give you a brief insight into what's going on, we are calculating a life cycle assessment. What is that? That is basically the calculation of the environmental impact for a material from the raw material to the powder as it's shipped to the customers. That accounts for example, climate change aspects, for toxicity, for freshwater use, for land use, for resource use, for ozone depletion, and ultimately, of course, also CO2 release. And we had done and completed that life cycle assessment for our whole TPU and PP portfolio, which is the baseline firsthand for the reduction of the environmental impact, but also for the compensation of carbon emissions, which we cannot reduce further. In the end, we have a complex production chain, and of course, we want to have a zero impact material, but there will always be a remaining energy that needs to be used, and that cannot be reduced to zero. And only for the remaining footprint, basically, we offer carbon compensation, which is already available for TPU and PP, and can be purchased with the materials as an add-on and a feature to have really a life cycle neutral product on hand. Next to the assessment, the reduction, and the compensation, of course, we need to look into recycling streams. And to give you an idea, for example, on TPU, we had made some studies to either downcycle material in injection molding process, or even use parts, basically regrind them, put them into recycled filament and print them again on a filament printer. So things like that are basically technically feasible, and our work at the moment is being done into establishing a real recycling stream that unused material or end-of-life parts can be taken back with our promise that the parts will not be burned somewhere, but that the material itself will have a second life. And I think that's a very, very important aspect in our circular economy activities, so that we reduce the number of materials that are released to the world and reduce the environmental impact wherever we can. And with this, I'm at the end of the presentation, looking forward to your questions. And again, emphasizing that it's about the togetherness in creating value for our customers, and our customers could be the end user of the additive manufactured part, and jointly driving the industrialization forward as a team. So this is my question to, if there's any question or request, please reach out to us. We'll be happy to assist, provide answers to your questions, and helping you scaling your additive manufacturing process. Thanks a lot.
Thanks, Stefan. Appreciate it. Appreciate your thorough working through it and talking about all the different applications and the materials. Monitoring the chat here, haven't gotten any more questions there. I think you can feel free to unmute yourself as well, right, Alex? We can do that and and just ask. Go ahead and ask your questions verbally, or you can type them in. So we'll hang out for a little bit here and wait and see if we get any other questions. One, as you're thinking through, one of those that I get a lot is on the sustainability side of things, right? That's getting more and more important as we go, and as 3D printing gets more prevalent, the question of sustainability is a big one. So BASF is serious about that as a company, right? So big BASF is very, very serious about it, and we are as well. One of the questions I often get is, what is an LCA? People ask for an LCA, say, what's the LCA of your material? And so I'm not going to pretend that I understand it completely, but I've gotten some information there, and I've read through the LCA that we provide. And so an LCA is simply a life cycle analysis. Stefan, you touched on this earlier, but this is something that I think bears repeating. So the life cycle analysis is a full analysis that takes into account all of the energy, all of the resources that are required to produce the material, and in our case, also we can get into the resources that are required to produce the part, right? So really we can look at it all the way through. Our LCAs right now are really cradle to gate. So they're focused more on the raw material side, but these are things that we can also tailor. And if you've got a large application, if you've got the type of application that needs this type of information, we can definitely work with you on that application as well. I see we had a question about the presentation and whether or not it will be circulated. Great question, and Alex, thanks for answering that. But yeah, that's the recording will be made available at soon, right? And it'll be posted on social media, same way that you learned about the webinar. And reach out if you'd like a copy of the slides. I think we can do that, no problem. We probably won't broadcast those, but please reach out to Farsoon or sales at BASF 3DPS, and we'll definitely get you a copy of the slide deck. All right. Well, if there aren't any other questions coming through, then I just wanted to wrap up a little bit with a couple of general. Did have another one. Yeah. Thanks, Simon.
Thank you.
Yeah, that's good. That's a really good point to bring up. So, the support that we offer especially in North America, right? That's what I'll speak to, because that's what I know the best. So the support that we offer with BASF powder in the Farsoon platform is number one. We have, and I think Stefan showed this in the presentation, but we have the starting parameters for each material in the Farsoon platform. The vast majority of our materials, so the TPU, the PA11 grades, those we also have detailed parameters for. So Farsoon has detailed parameters. So you'll get a machine that is ready to go with parameter sets for the materials that you have. We have a technical team member in North America with over 10 years of experience in SLS, and so his name is Todd McAnally, and Todd would also be available for support questions. Todd has supported our customers from anything from telephone and email support all the way to a week-long visit for a large application to make sure that the material's up and running and things are working as they should. So those are the areas of support that BASF would provide. Farsoon would also provide support from a standpoint of technical and mechanical support for that application and for those materials. Very good. All right. Well, just to wrap up a little bit, probably our two big materials that I really want everyone to come away from are the TPU and the PA11. Right. So the TPU, they both are easy materials to print with. They have unique properties. If you are looking for an elastomeric material for an application that requires skin contact, that requires excellent durability and all kinds of flexibility and functionality, the TPU is a fantastic material to consider. If you're looking for a PA12 replacement, right, something that's as easy to print as PA12, has some better mechanical performance, has a better sustainability footprint, PA11 is a fantastic option for you to look at as well. And we'd be happy to help you with making those selections. So yeah, I think looks like about it for the questions. And so I'll wrap it up and just take the opportunity to thank you all for being here today. Appreciate your questions, appreciate your attention, and yeah, please reach out to us with any other questions, either at the email address below there or get through Farsoon, and they can make the connections as well. So thanks everybody. Appreciate you being here today.
Thank you. And thanks to the
All right.
Farsoon team.
Yeah.
Farsoon team to host us.